the previous videos, we mentioned about the detailings of the beam, the slab, as well as the column. We observed that there are a lot of informations to be presented in those detailings, and these detailings needs to be read in concurrent with the structural keyplan in order to know which structural element it exactly means. Therefore, you know that the detailings should always come together with the structural keyplan, and the informations as presented in the detailing needs to be in line with the structural keyplan. So far we mentioned about the beam, the cross sections of the slab, as well as the column schedule. In these videos, we're going to proceed with our discussions in terms of the foundations. When we talk about the foundations, there are two main types of foundations. The first one, it will be the footing. The other one, it will be the pile caps. The footings are normally used when the soil have a good bearing capacities. For example, the buildings are built on top of the mountains, over some hills, where in order to construct the building, the respective earthwork, it will be cutting a layer of the soil from the hill or from the mountain, where the soil has already been quite adequately compacted by the nature over a long period of time. That means the soil is more or less fully consolidated. In order for you to know the bearing capacity of the soil, you would require the site investigation report, which is normally dealing with the soil properties. You will also need the data in terms of the soil bearing capacity for you to design the footing, especially in terms of the areas required for the footing subjected to a certain levels of loads. Another types of foundations, it will be the pile foundations. There will be piles being driven into the soil, either through the frictions or through embedding with the hard strata underneath the soil, that the building is actually sitting onto the piles. There will be pile caps grouping the piles together in order to ensure the stability of the piles as well as the stability of the entire structures. Now you need to know that the footings and the pile caps, they are two different things. Not only their applications are different, their design and working mechanisms are also different. You must not confuse with that. And the selections of the type of the foundations, it will be very much dependent on the soil property, which sometimes, even without the soil investigation report, more or less you can predict which type of foundation it is going to be used in that particular structures. Normally there will be a visit to the site to observe the conditions of the site as a part of the preliminary study. Normally during this site visit, they will observe the access to the site, the drainage, where it comes, where it goes, the soil conditions, the flora and fauna, the utility, and etc. Maybe in future, if we have chance, we will discuss a bit about the feasibility study before the project starts. As far as this course is concerned, we deal solely with the structural design. By looking at the soil conditions, you can simply grab some soil in your hand and do some simple testing and observation. Observe the color of the soil, observe the texture of the soil. More or less you are able to determine what kind of soil it is for you to predict the potential bearing capacity of the soil. Although the value may not be as exact, but it is a good reference to you, especially when you know about the soil mechanics and the geotechnical engineering. Based on the type of the soil, more or less you will know the range of the bearing capacity, which you can make certain assumptions during your design. You may also observe the flora and fauna. When you see those big trees, most likely the soil are relatively good. If you see grasses, barely see some tall and big trees, most likely the soil conditions may not be as good. The color of the soil. If the soil is very dark in color, brownish with a lot of humus, most likely it is a pit. When you encounter pit, that means the footing is out of the option. You will have to go for the pile foundations. You may observe from the development nearby or based on the historical records that the region nearby, what kind of foundations are commonly being used. If most of the construction nearby is dealing with the pile caps, most likely you're going to design for the pile foundations. Of course, this is just an initial judgment for you to decide what kind of foundations you're going to use in the case that you do not have soil investigation report. Of course, the best option for you is to have access with the actual soil investigation report for you to proceed with the design. Next, you want to have the economical design for the foundation as well. However, at the same time, you need to strike a balance in terms of the practicality, particularly for the supervision purposes, which in this case, you will need to standardize several designs and limit the numbers of the foundation design within the project not to be too many. And most likely you're not going to use the same pile caps throughout the entire structures, as this is also not economical. You should allow a range of the numbers of the piles within certain pile caps, most likely between 1 unit to 4 unit piles. You will need to provide detailings to indicate the dimensions, the reinforcement bar, the lapping, as well as the positions of the piles. And the appropriate size of the pile cap will be given in the lectures for the course Reinforced Concrete Design 2. Now let us look at some examples in terms of the detailings, as well as the structural key plan for the foundations. This is a typical key plan for the foundations, which is pile foundations. There will be grid lines both in the y-axis and the x-axis. The dimensions are clearly indicated, and the grid lines are supposed to be in line with the grids as given by the architecture plan. Within the key plan, you will see the positions of different piles as well as the pile caps. There will be 2 pile caps, 3 pile caps, and so on so forth. Every single type of the pile caps needs to be properly leveled so that their design can be referred from the pile caps schedule. The locations of the piles needs to be clearly indicated. And remember that the center of the reactions given by the pile should theoretically be aligned with the center of gravity of the pile caps, as well as in line with the center of the load acting on the column. It is only when these 3 are in the same axis, same locations, the pile caps is functioning at its best conditions. We also mentioned that previously in our previous video that you produce your structural key plan, which sent to the construction site for pile driven activities, which after the piles has already set, done the piling process, there will be a process of surveying the exact positions of the piles. See if there is any misalignment or any variations in terms of the positions after being driven into the soil. Then there will be a drawing produced, which is known as the Asp Drawing. This Asp Drawing will indicate to you the current locations of the pile in relative to the initial intended positions. There is no perfect in the construction work, especially when you come to the site activities. What you draw, you may imagine it in the most ideal situations, where everything is perfect into the accuracy in mm's. But what is actually happening on site, there will definitely be some variations from your original technical drawing. Even the measurements also, I'm talking about the survey result. In terms of the positions of the piles, the accuracy can only reach up to 4 mm plus minus. That one is already considered to the industrial standards. Therefore, on basis of the as-built drawing, you will need to study the center of the reactions given by the piles, and most likely you're going to modify the bit in terms of the dimensions and size of the pile caps to ensure their center of the reactions is in line with the center of gravity as well as with the center of load acting on the column. You know that again, there is no 100% perfect work. The perfect accuracy is nearly impossible to be maintained, at least by your all means to minimize the eccentricities among these three center points. This will minimize the potential of having undesired stress and loads acting on every single element of the pile foundations. Now that let's say we have confirmed, we know all this is properly done, and then you know what are the sizes of the foundations, we will proceed with the classifications and grouping of the pile caps. Normally it is grouped in accordance to the numbers of piles. There will be one design for 1 pile caps, another for 2 pile caps, another for 3 pile caps, and so on and so forth. We also mentioned in the previous videos, for the key plan of the pile caps, you need to also indicate the columns numbers so that the contractor do not need to flick here and there, because as they are constructing the pile caps, they also need to know the size of the column for them to provide the starter reinforcement bar, which are meant for the lapping between the columns of different stories. Next, you will need to refer to the exact locations of the pile caps as well as the piles. Normally, the grid line here are meant for the positionings of the columns. It can be either on the edge of the column, it can also either to the center of the column, which sometimes it can be at the offset distance from the column. However, your pile cap design will need to be positions at the centers of the columns. Therefore, most likely your positions of the pile cap are not clearly indicated by just the grid line. Normally, there will be an offset distance from the grid line, which you need to clearly indicate its distance. Now we will proceed with the schedules of the pile foundations. You need to clearly indicate the numbers of the pile caps. Provide illustrations in terms of the plan view, as well as the x-axis view and y view. For every types of the design, there will be one column of this. First, let us look at the plan view. You need to clearly indicate the dimensions of the pile caps, the positions of the piles. The dimensions of the pile caps needs to be clearly indicated. The positions of the column needs to be clearly indicated. The positions of the pile needs to be clearly indicated against the centers of the columns, and you need to provide the amount of reinforcement bar in both directions. From the plan view here, you may not be able to decide which one is the main, which one is the secondary reinforcement bar. This is only when you provide the x-axis view and the y view. And then for the access view here, you will see the numbers of the piles here. And normally when the piles are being set into the soil, they are checking the last 10 blows, driving the piles into the soil, and the settlements of the piles in the soil cannot exceed certain limits. For example, cannot be more than 25 mm to confirm it is set. Next, the piles will need to be cut to the intended length, hack the concrete, expose the reinforcement bar, and this reinforcement bar is to be bent within the regions of the pile caps so that it is effectively embedded in the pile caps to ensure the continuity between the piles and the pile caps. There will be a layer of the lean concrete which is about 50 mm thick. The grade of the lean concrete is C15 in order to separate the pile caps of it with the soil underneath it. And then this pile head need to embed in the pile cap for at least 100 mm. You need to clearly indicate the anchorage length of the reinforcement bar in the piles inside the pile caps. Then you will need to indicate the height of the pile caps as well as the reinforcement bar provided in the pile caps. Be careful with the locations of the main and the secondary reinforcement. And the reinforcement are bent in the U shapes. And because of the height of the pile caps here, you might need to provide the longitudinal reinforcement bar in the form of the cage in controlling the cracking on the surface of the pile caps. This is the typical design of the reinforcement bar for the pile cap, where you assume all the loops are coming from the top and the pile caps are always in compression. The reinforcement bar are provided as a bending resistance with the effective span supported by the piles underneath the pile caps. In the case that you are dealing with tall buildings, where the buildings may be subjected to the lateral load, there could be some foundations. Instead of undergoing compressions, there could be some uplifting actions. That means you need to provide reinforcement bar on top of the pile caps. That means there is chance for the moments to add on top of the pile caps due to the uplifting of certain foundations of the structures, which in this case is a low-rise building, and you expect the weight of the structures as well as the aspect ratio of the structures, which is the width of the structures as compared to the height of the structures. It is relatively short and bulky, that the chances of uplifting of certain foundations is rather rare. Then you may provide the reinforcement bar something like this only, which in this case the top reinforcement bar of the foundations is not required. You need to indicate the existence of the stump as well as the reinforcement bar, how you want it to be lapped with the reinforcement bar in the column, which in this case there will be continuous reinforcement bar from the pile caps into the stump until go above the beam, and there will be lappings with the reinforcement bar in the columns. Clearly indicate the reinforcement bar provided as well as for the longitudinal reinforcement bar at the side of the foundations. This is the YY view. Because of the triangle shape of the pile caps, the center of gravity of the pile cap varies slightly. That's why you see the column is not at the middle positions of the base of the pile caps. Similar, all the details need to be properly provided. As there are so many informations to be incorporated here, Make sure they are neatly presented in order to avoid ambiguities and confusions by the contractors. Now we have done the power caps. You know that so many informations need to be provided, as well as there are many considerations. That is the reason that you need to have strong fundamentals in the theoretical aspects, as well as exposure to the practices in the construction site. And all this need to be incorporated in your design.